Welcome to this video lecture on the subject electromagnetic fields. So in this lecture we are going to discuss about introduction to electromagnetic fields. So first of all we can see these pictures. So what do we infer from these pictures? So first one gives the static electric field originating from the positive charge and ends at the negative charge, where the source of the electric field is the charges. So it may be positive charge or it may be negative charge. And in the second picture we are seeing the static magnetic field from the magnet, where we have a south pole and north pole, and the direction of the magnetic flux lines are from north pole to south pole outside the magnet and south to north inside the magnet. So introduction to electromagnetic fields. So here the electromagnetics is the subject where we study the effect of charges at rest and charges in motion. Because in some special cases of electromagnetics we study electrostatics, that is the charges at rest, and magnetostatics, it is the charges in steady motion, and electromagnetic waves where waves are excited by the charges in time varying motion or accelerated charges. So accelerated charges produce the electromagnetic waves. So this is the introduction to what we study in the electromagnetic fields. So consider a transmitter and a receiver. So here these are connected by the field, that is the electromagnetic waves, which is originating from the electromagnetic field. So when an event in one place has an effect on different location, so that event being connected by a field, so the field is the spatial distribution of a quantity. So it can be either a scalar or vector in nature. So in electric and magnetic fields, there are vector fields with three spatial components. It varies as a function of position in three-dimensional space as well as time. So these are governed by the partial differential equation derived from Maxwell's equations. So a scalar is a quantity having only amplitude and possibly phase, and examples are voltage, current, charge, energy, temperature, etc. So vector is a quantity having a direction in addition to an amplitude and possibly phase. So examples are velocity, acceleration and force. So fundamental vector field quantities in electromagnetics are electric field intensity, where we measure the electric field strength in terms of volts per meter, and electric flux density means the electric displacement, it measured in coulombs per meter square. And in magnetic field we measure magnetic field intensity as magnetic field strength in terms of amperes per meter, and magnetic flux density in teslas or Weber per meter squared. So these are the important parameters in electromagnetic fields. And for understanding the electrostatics, we must know the Coulomb's law, where the Coulomb's law is obtained from an experiment. It shows that electric force between two charges is proportional to the product of charges and inversely proportional to the distance between them. So Coulomb's law is governed by the equation of force, where it is related to uh, equal to K into Q1 Q2 divided by R square. It gives the magnitude of electrostatic force. And Coulomb's law gives the important relations that force is along the line connecting the charges, and it is attractive if the charges are opposite, and it is force is repulsive if they are the same. And unit of charge is coulombs. In the force equation we use the term K, but it is equal to 8.988 into 10 power 9. Charges produced by rubbing are typically around a microcoulomb. 1 microcoulomb is 10 power minus 6 coulombs. So the proportionality constant can also be written in terms of epsilon naught, where it means permittivity of free space. The permittivity means ability of a substance to allow the electric field or store the electric field. So we can rewrite the force equation using this relation. So we can have a small assessment. First of all, Coulomb's law is employed in which of the following? Electrostatics, magnetostatics, electromagnetics, and Maxwell theory. So the answer is electrostatics. Second question, find the force on the charge 2 coulombs in a field of 1 volt per meter. So how to derive? It is related by the electric field intensity and force equation, where we can write F equal to Q into E. So charge value and electric field intensity value are substituted to find the force, 2 newtons. These are the references. So thank you for listening.